The Boeing 727 helped turn jet travel into an everyday American experience. Then, 3 major crashes struck within months, shaking public confidence in one of the country's newest airliners. Through the accidents that followed, this video traces how the jet became part of America's dangerous transition into modern air travel. Don't forget to subscribe to Terra Obscura. The final transmission from United Flight 389 carried no hint of alarm. A controller corrected the crew's reading of the local altimeter setting, and the pilot calmly repeated it. Radar evidence would later show that their Boeing 727 was already far below its assigned altitude. The jet was barely 10 weeks old. 24 passengers were traveling from New York's LaGuardia Airport to Chicago O'Hare. 6 crew members were aboard. Captain Melville Towle had more than 17,000 hours of experience. He had only 59 hours as captain on the type. Flight 389 climbed to 35,000 feet after leaving LaGuardia. The journey remained routine until air traffic control began directing the descent over Lake Michigan. The first clearance took the aircraft to 24,000 feet. It was later cleared to 14,000. At 21:11, the crew received permission to descend to 6,000 feet and acknowledged the limit correctly. The Boeing continued west at an average descent rate near 2,000 feet per minute. Nothing in the radio exchanges suggested mechanical trouble. The crew reported no emergency. A military radar network provided the only surviving record of the aircraft's vertical path. One height reading placed it near 16,500 feet about 6 minutes before impact. Another placed it close to 2,000 feet as the crew spoke with Chicago approach. That second reading came while the flight was still cleared to remain at 6,000 feet, allowing for radar uncertainty. The jet may have been only 500 to 2,000 feet above the lake. The pilots continued discussing their approach, as though the descent were normal. Seconds after the final exchange, the aircraft reached the surface. The Boeing struck at roughly 200 knots with its nose slightly raised and its right wing low. All 30 people aboard died. The impact scattered wreckage across the lakebed in water about 250 feet deep. Search vessels found the first floating debris nearly 5 hours later. Recovery crews eventually brought up most of the aircraft by weight and recovered every occupant. They found the outer casing of the flight data recorder, but the metal tape inside it was missing. Investigators had the wreckage and radar records. Recorded air traffic control exchanges supplied the only surviving words from the crew. The engines indicated that all 3 were operating at impact. The landing gear was retracted, and the wing devices were in their normal cruise positions. One instrument soon became central to the inquiry. The Boeing carried 3 pointer altimeters. One hand represented hundreds of feet. The other 2 represented thousands and tens of thousands. A correct reading required the pilot to combine them into one altitude. At 6,000 feet, the display could be mistaken for 16,000 during a rapid scan. The descent was continuous, so every pointer remained in motion. Workload increased as the crew prepared for the approach and searched outside for traffic. The weakness of this design was already documented. A Naval Research Laboratory study had compared 4 altimeter types shortly before the accident. During more than 1,000 readings by pilots, the 3-pointer model produced 80 errors. Every alternative produced 26 or fewer. A 10,000-foot reading error was therefore plausible, although it could not be proven. The other crew members would also have needed to miss warning markings that became more visible below 10,000 feet. Investigators found no evidence that the altimeters had malfunctioned. They could establish only that the aircraft continued below its clearance while the crew remained unaware of the danger. The final report declined to name a definite cause. It concluded that the reason Flight 389 failed to level at 6,000 feet could not be determined. This was the first fatal accident involving a Boeing 727. The evidence described a jet that appeared to be functioning normally when it reached the water. What remained unanswered was how an experienced crew could pass through a firm altitude limit while calmly preparing to land. For investigators, the deeper concern was an instrument that could display accurate information in a dangerously confusing form. The aircraft offered no final answer, yet its loss exposed one of the analog jet age's most troubling blind spots. Cincinnati's runway stood on high ground above the Ohio River Valley. From an aircraft circling at night, the scattered lights below could resemble a safe path toward the airport. They could also hide how sharply the terrain rose before the runway began. American Flight 383 was approaching that landscape with 2 captains at the controls. Captain David Thielen sat in the right seat as the company check airman. Captain William O'Neill occupied the left seat while completing his qualification on the Boeing 727. Both men had more than 14,000 flying hours. The aircraft had entered service only months earlier. It carried 56 passengers and 6 crew members from New York to Cincinnati. A delay at LaGuardia had placed the flight about 20 minutes behind schedule. The crew shortened its route and reached Cincinnati at high speed. A line of showers was moving toward the airport. The pilots reported that they could see the field and requested a visual approach to runway 18. This allowed them to leave the published instrument procedure and guide the aircraft by outside reference. The reported visibility still met the required conditions, yet the picture was changing quickly as rain spread across the approach path. Flight 383 leveled at 2,000 feet east of the airport. This placed it about 1,100 feet above runway elevation. The Boeing then flew north before beginning a wide turn across the Ohio River Valley. Its track was much farther from the runway than the visual pattern used in American Airlines training. That distance required the crew to preserve altitude longer or use a shallow descent until the turn toward final was secure. Instead, the aircraft began descending while still on the base leg. It was also carrying more speed than desired. Flap extensions and other landing tasks became concentrated late in the approach. The Boeing 727 could lose height quickly at low thrust, as its high-lift system added drag. Investigators found no flaw in this behavior. It was a known characteristic that demanded careful energy management close to the ground. Rain reduced the view toward the airport. The tower asked whether the pilots could still see the runway. The crew replied that they could barely hold it in sight and intended to use the instrument landing system. That exchange came only seconds before impact. By then, the aircraft had already descended below airport elevation. The flight recorder showed a steady descent near 800 feet per minute for much of the base leg. 20 seconds before impact, the rate increased to roughly 2,100 feet per minute. The crew then reduced it, though the aircraft remained far too low. The altimeters added another layer of difficulty. American used drum pointer instruments that displayed thousands of feet through a rotating drum and hundreds through a needle. Two showed height above the airport, while the third displayed altitude above sea level. When the aircraft descended below runway elevation, the two primary instruments passed through zero and began showing negative height. Reading that presentation required close attention, because the relationship between drum and pointer changed below zero. Investigators considered a misreading possible. They found no evidence that any altimeter had failed. The terrain could also have supported a false sense of safety. The river valley lay about 400 feet below the airport. Residential lights near the water offered little indication of the wooded slope rising ahead. Under reduced visibility, those lights may have appeared compatible with a normal altitude. These remained contributing possibilities. The central failure was clearer. Neither pilot maintained an effective instrument cross-check, while their attention was directed outside. The right wing struck a tree 2 miles north of the runway. The aircraft was 225 feet below airport elevation and still turning toward final. It moved through low vegetation before colliding with larger trees. An intense fire followed. 3 occupants were thrown clear and a 4th escaped through the missing front section. 58 people died. The wreckage showed that the flight controls and all 3 engines had been operating. Investigators found no design deficiency in the Boeing 727 that explained the accident. The Civil Aeronautics Board placed the probable cause on the crew's failure to monitor the altimeters during a visual approach in worsening visibility. It also found a cockpit burdened by late configuration changes and a desire to complete the arrival quickly. A visual approach can feel simpler because the runway is already in sight. Flight 383 showed how fragile that advantage becomes when the view begins to close. Once outside, references became unreliable. The instruments were the only dependable measure of height. For nearly 2 minutes, the aircraft descended without that protection being used effectively. The first officer reached for the throttles because the runway was still far below. The captain pushed his hand away and told him to wait. Their Boeing 727 was already descending at nearly 3 times the rate United considered normal. Flight 227 was continuing from Denver to Salt Lake City after a crew change. 85 passengers were aboard with 6 crew members. The first officer was flying under the captain's supervision as the aircraft descended through cloud. At 16,000 feet, the engines were brought to idle and the speed brakes were extended to lose height quickly. The field came into view near 11,000 feet. The speed brakes were retracted as the crew continued slowing. The landing gear came down and the flaps eventually reached 40 degrees. At 10,000 feet, the aircraft was still moving at 250 knots. The pilots reported the runway in sight and canceled their instrument clearance. They remained with the controller for traffic information while continuing visually toward runway 34 left. Flight 227 crossed the outer marker more than 2,000 feet above the normal glide slope. Its speed was still close to 200 knots. The crew now had to lose a great deal of height while preparing the aircraft to land. A normal approach would have required a descent near 800 feet per minute. The Boeing was coming down at roughly 2,300. The high lift system gave the 727 excellent performance from shorter runways. With full flaps extended and the engines near idle, it could also build a steep descent very quickly. Both pilots were relatively new to the aircraft, and the margin for correction was shrinking. The first officer recognized the developing danger and began adding power. The captain stopped him. Around half a minute later, the first officer moved the throttles forward again. The captain then took control and advanced them toward maximum thrust. Early jet engines needed time to accelerate after operating at idle. Witnesses heard the engines begin to respond, though the command came too late to overcome the established descent. The main landing gear struck the ground 335 feet before the runway threshold. Both assemblies began tearing away as the fuselage slammed onto the pavement. The aircraft slid for almost 2,840 feet. It veered off the right side of the runway and stopped with its nose gear still extended. The impact itself had been survivable. The right landing gear had punched through the lower fuselage. It ruptured fuel lines beside electrical generator leads. Fuel met sparks within seconds, and flames entered the passenger cabin. The fuel tanks remained intact. The broken lines continued feeding the fire because the boost pumps were still operating. Heavy smoke cut off escape routes as the blaze moved forward. Passengers crowded toward the front door. Their movement delayed a flight attendant who needed to reach it. The second officer opened the exit and began directing people onto the slide. 50 people escaped the aircraft, though 2 passengers later died in hospital. The final toll was 43 passengers, while all 6 crew members survived. Investigators found that impact injuries had not prevented anyone from escaping. The fatalities resulted from the fire and the conditions it created. The Civil Aeronautics Board placed the probable cause on the captain's failure to arrest the excessive descent in time. His jet training had once been terminated after poor judgment and weak adherence to procedures. Later evaluations remained inconsistent. The inquiry found that the engines and flight controls had been capable of normal operation. Power had simply been applied too late. It also questioned how earlier concerns about the captain's approach technique had failed to keep him from command. The response reached far beyond the cockpit. United began seating flight attendants near emergency exits during takeoff and landing. Federal rules later demanded flexible fuel lines, while generator wiring was moved farther away. A landing that should have left most occupants alive became a defining cabin safety case. Its legacy can still be found beside modern aircraft doors and beneath their floors, where survival depends on decisions made long before anyone needs to escape. The Boeing took 11 seconds longer than expected to leave the runway. Its crew felt the resistance and used maximum thrust. Once airborne, the abnormal drag seemed to disappear. The heat it had created remained inside the left main landing gear. Mexicana Flight 940 was scheduled from Mexico City to Los Angeles with stops in Puerto Vallarta and Mazatlan. The Boeing 727 carried 159 passengers and 8 crew members. Captain Carlos Guadarrama had flown the type since 1973. His wife and 2 children were among the passengers. By 1986, Mexicana operated one of the largest Boeing 727 fleets in the world. The American Trijet had become central to routes across Mexico and into the United States. The aircraft was only 5 years old. It had arrived from Chicago earlier that morning after technicians addressed a report of uneven braking. Further maintenance entries were examined in Mexico City before Flight 940 was released. The investigation documented those entries, yet never established why the left outboard brake later failed to release fully. During taxi, the captain sensed that the aircraft was being held back. The same resistance continued during the takeoff roll. Even at maximum power, acceleration remained slower than expected. Investigators confirmed that the aircraft was below its permitted takeoff weight. Engine performance was normal. The resistance came from the number 1 brake assembly on the left main gear. A dragging brake converts motion into intense heat. This one remained partly applied as the jet accelerated along the runway. By the time the aircraft lifted off, parts of the assembly had reached temperatures capable of melting its internal material. The landing gear then retracted into the wheel well. Airflow could no longer cool the overheated brake effectively. Heat spread into the wheel and the tire beside it. The tire should have contained dry nitrogen. Instead, it had been serviced with compressed air that contained oxygen. As an overheated tire breaks down, its inner material releases flammable gases. Inside an oxygen-rich tire, those gases can ignite without an outside spark once the temperature becomes high enough. About 14 minutes after takeoff, the Boeing was nearing cruise altitude when the tire exploded. The blast tore through the left wheel well. Fragments severed hydraulic lines and electrical cables. A fuel line supplying the number 1 engine was also ruptured. The cabin lost pressure. Captain Guadarrama requested a descent and asked to return to Mexico City. The crew put on oxygen masks and began an emergency descent. Fuel continued escaping under pressure as the fire spread through the lower rear fuselage. High-speed airflow fed the flames along the aircraft's exterior. The crew reported increasing control difficulties. The fire was attacking the structure around the rear fuselage, where the Boeing 727 carried all 3 engines and its tail surfaces. Only about 4 minutes passed between the tire explosion and the final breakup. The weakened fuselage separated behind the wing wings. The tail section fell away with the engines and the surfaces needed for pitch control. The forward section rolled out of control before striking mountainous terrain near Maravadio. All 167 people aboard died. Flight 940 remains the deadliest aviation accident on Mexican soil and the deadliest involving a Boeing 727. Early claims of deliberate sabotage were rejected after laboratory testing found no explosive residue. The official investigation traced the initiating event to the dragging brake and the extreme heat it produced. Investigators concluded that compressed air inside the tire allowed an internal ignition that nitrogen would have prevented. The resulting blast ruptured nearby systems and started the fire that weakened the fuselage. The report left an important question unresolved. It identified the brake malfunction, yet did not determine why that brake had dragged during takeoff. In 1987, the Federal Aviation Administration issued a directive for affected large transport aircraft. Tires on braked wheels had to contain dry nitrogen or another inert gas with tightly limited oxygen content. Flight 940 exposed a danger that began below the cabin floor and remained hidden from the crew. A dragging brake and an oxygen-rich tire turned ordinary takeoff heat into an uncontrollable fire. By the time the pilots understood the scale of the emergency, the decisive chain had already been building since the runway. Everyone aboard National Flight 193 survived the impact. The Boeing came to rest in 12 feet of water with part of its fuselage still above Escambia Bay. 3 passengers would still be lost before rescue was complete. The flight was finishing a short hop from Mobile to Pensacola, with 52 passengers and 6 crew members. Captain George Kuntz had more than 18,000 flying hours, including over 5,000 in the Boeing 727. First Officer Leonard Sanderson was flying beside him. Pensacola's main instrument runway had been closed for reconstruction. The remaining option was runway 25, which had no instrument landing system. The crew would receive an airport surveillance radar approach instead. A controller would watch the Boeing on radar and issue headings toward the airport. The pilots still controlled their descent. They needed advance notice of the final approach fix, so the aircraft could be configured before reaching it. The controller turned Flight 193 onto final about 4.5 miles from the runway. Standard procedure called for an interception at least 8 miles out. He also failed to warn the crew that the descent point was approaching. By the time the Boeing rolled onto final, the crew had passed the approach fix. Their landing checklist had not begun. The landing gear remained retracted, and the flaps were only partly extended. Captain Kuntz started down toward the minimum altitude of 480 feet. The aircraft was still too clean, and its speed remained high, so he reduced engine thrust. The crew then lowered the gear and extended the flaps to 25 degrees. The added drag arrived, while the engines remained near idle. The descent rate increased toward 2,000 feet per minute, almost twice the rate the pilots expected. Sanderson did not make the required altitude callouts. He later explained that the approach had unfolded so quickly that his mental sense of time never reached the point where those calls normally began. Both pilots also struggled with the drum pointer altimeters. A rotating drum showed thousands of feet while a needle displayed hundreds. During a rapid scan, 500 feet could be mistaken for 1,500. The ground proximity warning system activated near 500 feet. The crew interpreted the alarm as a response to the high descent rate. Kuntz eased back on the controls while the flight engineer believed he had been told to silence the warning. The alarm stopped after 9 seconds. Its silence coincided with a slight reduction in the descent rate, convincing the captain that his correction had solved the problem. The Boeing was still below the minimum altitude. The flight engineer reset the system soon afterward. It had too little time to restart. Sanderson finally recognized that the aircraft was only about 50 feet above the surface. Flight 193 struck Escambia Bay, roughly 3 miles short of the runway. The impact tore open the lower rear fuselage and damaged the cabin floor. The aircraft remained largely intact before settling tail first into the water. Water entered through the damaged rear section as passengers moved toward the exits. Some escaped onto the wings while others entered the bay. Crew members returned through parts of the flooded cabin to search for anyone left behind and recover life vests. Many passengers did not know where those vests were stored. 24 people believed the seat cushions could provide flotation. The cushions on this aircraft were not approved for that purpose, and several came apart in the water. 3 passengers drowned after leaving the cabin. Tugboat captain Glenn McDonald had watched the Boeing descend through darkness and fog. He turned his barge toward the wreckage and began pulling people from the water. Local fishing boats soon joined the rescue. Most survivors were recovered within 30 minutes. Captain Kuntz placed seriously injured passengers on top of the exposed fuselage while they waited for help. Investigators found no failure in the engines or flight controls. The NTSB placed primary responsibility on the crew's failure to monitor altitude and descent rate during the rushed, non-precision approach. It also cited the missing callouts and delayed response to the terrain warning. The controller's late vector was listed as a contributing factor. It compressed the landing preparations into the part of the approach that should have been devoted to monitoring the aircraft. By 1978, the Boeing 727 had become an established American workhorse. Flight 193 showed that a routine 20-minute journey could still overwhelm the procedures and people surrounding it. The accident left two distinct lessons. A hurried approach can erase altitude awareness before the crew feels that anything is wrong. Survival after impact also depends on passengers understanding the equipment available around them. The Boeing survived its arrival in the bay. The final 3 lives were lost after it had stopped moving. Juneau's airport sat at sea level beneath mountains that rose directly across the approach path. In 1971, pilots could follow a radio course toward runway 8, yet the system did not tell them their distance from the airport directly. That distance had to be determined through intersecting radio signals. Alaska Airlines Flight 1866 was traveling from Anchorage to Seattle with several intermediate stops. The Boeing 727 left Yakutat for Juneau carrying 104 passengers and 7 crew members. Captain Richard Adams had almost 14,000 flying hours. First Officer Leonard Beach was flying the aircraft. The arrival required a non-precision instrument approach. A localizer guided the aircraft toward the runway, though it offered no vertical guidance. The crew had to identify several points along the route before descending to lower altitudes. Those points were created where the localizer crossed radio bearings from the Sisters Island navigation station. Howard came first. Rockledge followed, then Barlow marked the final approach fix. There was no distance measuring equipment to provide a direct mileage reading. Cloud covered the mountains as the Boeing approached from the west. The crew entered a holding pattern at 12,000 feet while controllers handled another aircraft whose position had become uncertain. Flight 1866 helped relay radio messages during the delay. Investigators later considered this a possible distraction, though they did not identify it as the cause. When the approach resumed, the crew reported reaching Howard, while the aircraft was still far from its correct position. Their later conversation suggested that Rockledge and Barlow also appeared earlier than expected. Each apparent crossing allowed the aircraft to descend farther. The controller cleared the flight for the straight-in approach. Soon afterward, the captain reported passing through 5,500 feet and then 4,500. The pilots believed they were nearing Barlow. In reality, the Boeing remained more than 8 nautical miles west of that point. The flight recorder showed a steep descent from just above 12,000 feet. At one stage, the rate exceeded 6,000 feet per minute before the crew reduced it. Once they believed Barlow had been crossed, the published procedure permitted descent toward 1,000 feet. The aircraft was actually above the Chilkat Range, where the surrounding terrain rose much higher. The localizer still appeared normal. The Boeing was close to the correct inbound course, which made the false position more convincing. The problem concerned distance along the route rather than direction. The crew contacted Juneau Tower and reported Barlow inbound. Their voices carried no sign that they understood the danger. The aircraft struck a canyon slope at roughly 2,500 feet. It was still 18.5 nautical miles from the airport. All 111 people aboard died. At the time, it was the deadliest single aircraft accident in United States history. Investigators found no defect in the engines or flight controls. The altimetry system had operated normally. Tests of the recovered navigation equipment revealed no failure that explained the incorrect intersection indications. The Sisters Island station was checked several times. Ground inspections and test flights found it operating within limits. Investigators examined signal interference and compatibility problems, though none could be reproduced. The cockpit recording revealed that the crew did not listen for the coded identification of each navigation station after selecting its frequency. They also had access to other radio aids that could have provided independent position checks. Those aids were not used, though the approach procedure did not require them. The National Transportation Safety Board concluded that misleading information about the aircraft's progress along the localizer led the crew below the safe obstacle clearance altitude. The source of that information was never determined. Flight 1866 could not be reduced to a simple navigation mistake. The crew followed indications that appeared to place the aircraft farther along the approach, yet the available checks capable of exposing that error were either optional or left unused. Distance measuring equipment was later installed for the Juneau approach. Pilots could then compare each crossing point with a direct mileage reading. The accident showed why direction alone was not enough in mountain terrain. A crew could remain on the correct course and still descend toward the wrong point on it. The wide-body jet ahead of Flight 66 came within about 60 feet of the ground before climbing away. Its crew warned controllers that severe wind shear was pulling aircraft down near runway 22 left. Eastern Flight 66 heard the warning. By 1975, the Boeing 727 had become a familiar part of American air travel. The danger forming near John F. Kennedy International Airport was still poorly understood. Flight 66 was arriving from New Orleans with 116 passengers and 8 crew members. First Officer William Eberhart was flying the approach. Captain John Cleven occupied the left seat. Thunderstorms surrounded the airport while traffic continued toward runway 22 left. The airport's wind sensor stood near the far end of the runway. It did not reveal what was happening along the distant approach path. Several aircraft had already encountered sharp wind changes. A Flying Tiger DC-8 needed almost maximum thrust to reach the runway after meeting a powerful downdraft. Its captain recommended using another landing direction. The crew of Flight 66 did not hear that full report. Approach control described it only as a severe wind shift. Its airspeed fell and its descent rate increased. The crew began a go-around at low altitude, though the aircraft did not climb until it was close to the ground. Flight 66 heard this report and confirmed that it understood. 2 aircraft then landed without reporting serious difficulty. The danger seemed intense but inconsistent. The crew had already spent time holding near New York. Changing the landing direction could create another delay. The pilots continued while preparing for the reported shear. They planned to carry extra speed during the approach. The weather radar was placed on standby in case a missed approach became necessary. The Boeing 727 intercepted the instrument landing system and remained near the glide slope. Its airspeed stayed close to 140 knots. Near 500 feet, the rain became heavy and the headwind strengthened. The added airflow briefly lifted the aircraft above the desired path. The crew reduced thrust and lowered the nose to regain the glide slope. The wind then changed with extraordinary speed. The headwind disappeared as the Boeing entered a powerful downdraft. Airspeed fell from about 138 knots to 123 in only 2.5 seconds. The descent rate increased toward 1,500 feet per minute. The aircraft was now low on energy with little height remaining. Heavy rain reduced visibility. The sinking motion gave the pilots little physical warning. At about 150 feet, the captain reported the runway in sight. Attention shifted toward the visual landing picture, while the Boeing continued below the glide slope. 3 seconds later, the first officer called for takeoff thrust. The engines began responding, though the aircraft was already too low to recover. Flight 66 struck the approach lighting system about 2,300 feet before the runway. The towers tore through the aircraft before the wreckage crossed the airport boundary. The impact and fire took 113 lives. 11 people survived, most from the rear section. The National Transportation Safety Board found that the Boeing had encountered extreme winds associated with a powerful thunderstorm. The crew recognized the worsening descent too late as attention moved toward visual references. The board also stated that the winds may have been too severe for a successful landing even with a faster response. Continued use of the runway contributed after several crews had reported dangerous conditions. The investigation helped meteorologist Theodore Fujita define the localized downdraft known as a downburst. Later research identified the smaller and more concentrated microburst. The FAA developed the low-level wind shear alert system in response. Multiple sensors could now detect sudden differences across an airport, instead of relying on one distant reading. Flight 66 changed how aviation viewed wind shear near the ground. Training crews to react was no longer enough. Airports also needed a way to warn them before an invisible downdraft took away the energy required to escape. The Boeing 727 entered service when jet travel was still transforming America. Many airports had limited ground equipment, while training and safety systems were still adapting to faster aircraft. The 727 was built for that changing world. Its internal stairs allowed it to operate with less support on the ground. Its powerful high-lift system opened shorter runways to scheduled jet service. Those qualities helped bring modern air travel closer to communities across the country. For millions of passengers, the aircraft became part of ordinary American life. Its 3 engines and distinctive tail came to represent an entire period of aviation. The accidents surrounding it revealed how much that period still had to learn. Investigators confronted instruments that could be read incorrectly, even when they worked as designed. They examined airports that could not detect dangerous winds across an approach path. They also discovered how quickly a survivable impact could become impossible to escape. The responses changed aviation piece by piece. Cockpit procedures became more disciplined. Critical settings required visible confirmation instead of assumption. Airport wind detection improved as researchers learned to identify threats that had once been almost invisible. Aircraft systems changed as well. Essential instruments received stronger backup power. Fuel lines and electrical wiring were placed with greater attention to crash survival. The Boeing 727 remained in service through this transformation. The same aircraft that faced public suspicion during its early years later completed one of the longest careers in commercial aviation. Its losses did not point toward one repeating defect. They came from different weaknesses in the world around the aircraft. Weather science was incomplete, while navigation systems still depended heavily on interpretation. Human attention remained vulnerable inside a machine that moved faster than earlier generations of airliners. The 727 could be demanding. Its descent performance required careful energy management, and its cockpit belonged to the analog age. Yet trained crews operated it safely across millions of flights. Over time, aviation caught up with the aircraft. The 727 helped make jet travel common before every danger of the jet age was fully understood. The lives lost in its accidents carried a terrible cost. The lessons drawn from them became part of the safer system inherited by later generations. America's Trijet should be remembered for more than its shape or sound. It served long enough to witness the industry around it become stronger. Thank you for watching, and don't forget to subscribe to Terra Obscura.